Good morning students. In the previous video lecture on amines, you have studied about the introduction of amines, structure of amines, classification of amines, nomenclature of amines and physical properties of amines. So today we will study about the methods of preparation of amines. The first method of preparation of amines is by the reduction of nitro compounds. Both aliphatic as well as aromatic primary amines can be easily prepared by the reduction of corresponding nitro compounds. The first method of reduction is catalytic hydrogenation. So in catalytic hydrogenation, we are passing dihydrogen gas over the substrate in presence of platinum, palladium or nickel catalyst. Any of this is taken as a catalyst. Any one is taken as a catalyst. So the dihydrogen gas is passed over the nitro compound that results in the formation of respective amines. The reaction taking place is the reduction. That is, the addition of hydrogen takes place. Here I can write it generally as when RNO2. Generally, the nitro compound is represented as RNO2, where R may be an alkyl group or it may be an aryl group. So when this is subjected for hydrogenation, that is treatment with dihydrogen in presence of platinum, palladium or nickel catalyst. Anyone is taken as a catalyst. In presence of ethanol, the reaction takes place which acts as a solvent here. So the reduction takes place, addition of hydrogen takes place. Here oxygen is replaced by hydrogen. So here you are getting amine as a product. So when nitro compounds are subjected for catalytic hydrogenation in presence of platinum, palladium or nickel catalyst, there is a formation of respective amine. If R is an alkyl group, we are getting aliphatic amine. If R is an aryl group, we get the aromatic amine as a product. For example, if I take CH3NO2, nitromethane, if I take nitromethane as an example, this on reaction with hydrogen gas in presence of platinum or palladium catalyst in the ethanol medium, there is a formation of CH3NH2. NO2 is reduced to NH2 with the liberation of the molecule. So this is the byproduct. So nitromethane on reduction gives methanamine or methylamine. So this is our product. So instead of CH3, if I consider C6H5 or a benzene ring if it is present, that is nitrobenzene if I consider, when it is treated with the same reagent, that is hydrogen in presence of any one of the catalyst, the same type of reaction takes place. NO2 will be reduced to NH2. So we are getting here C6H5NH2. So the product is aniline. C6H5 is nothing but the benzene ring. Aryl group is present. So NO2 is reduced to NH2. So this is the aromatic primary amine. This is aliphatic primary amine. So like this, the catalytic hydrogenation takes place. This is the first way of getting amines by the catalytic hydrogenation. The second method of reduction of nitro compounds which gives amines is on reaction with metals in the acidic medium. Here we can take tin in HCl, or we can also take iron in HCl, or we can take zinc in HCl, which are used as a reducing agents in this process. So when nitro compounds are treated with such reagents, the reduction takes place and we are getting the amines. For example, if I take CH3, CH2NO2. So this is nitroethane. When nitroethane is treated with tin in HCl or iron in HCl, It results in the formation of CH3, CH2, NH2. The reduction takes place, that is, oxygen is replaced by hydrogen. So, the reduction is taking place here. 6 moles of hydrogen is undergoing replacement, that is undergoing reaction. There is a formation of ethanamine with the byproduct of water. So, by using this particular reagent, the reduction takes place. So, the product form is ethanamine. So, this is how the reduction takes place by using the metals in acidic medium. We can also take here iron instead of zinc and tin, which is the convenient or the better method of getting the amines. Even in place of alkyl group, if I consider the aromatic ring, that is aryl group, if it is present, nitrobenzene if I take, it is treated with iron in HCl or tin in HCl, results in the formation of aniline. So, NO2 is reduced to NH2. So, this is aniline. The reduction takes place. So, like this, the reaction takes place. The reduction of nitro compounds in the metals in acidic medium results in the formation of amines. Primary, aliphatic as well as aromatic amines are formed. As I said, instead of using tin in HCl and zinc in HCl, iron in HCl is more convenient method or more preferred method, because here one of the byproduct formed in this process is FeCl2, which is hydrolyzed further to release HCl, and because of this reason we can use iron in HCl, and even HCl needed for the particular reaction is in a very less quantity. As HCl is regenerated in this process, we can get back the HCl in the whole process. That's why less amount of HCl is required as a reagent. So this is the better reagent used in this particular reaction. Instead of using tin in HCl and zinc in HCl, iron in HCl is more preferred. I repeat, this is because FeCl2 formed in the process is undergoing hydrolysis, which results in the formation of iron hydroxide and HCl. As HCl is formed during the reaction, which is our reagent, so less amount of HCl is required to carry out the reaction. The second method of preparation of amines is ammonolysis of alkyl halides. So, from alkyl halides we are getting the amines. Alkyl halides means they are generally represented as Rx. So, here this Rx bond is cleaved by the treatment with or by the ammonia molecule. So, that particular reaction is considered as ammonolysis, breaking of CX bond. Here in alkyl group, the bond is exactly between carbon and halogen. The CX bond is cleaved by the ammonia molecule. That's why it is considered as ammonolysis. The whole reaction is carried out in presence of, it is carried out in a sealed tube at 373 Kelvin temperature. It is carried out in a sealed tube. So what is exactly the reaction? Alkyl halides are treated with ammonia in the ethanol medium. Here we are taking ethanol as a medium. In the alcoholic medium the reaction takes place. So this is a nucleophilic substitution reaction. Alkyl halide is treated with ammonia in presence of ethanol medium. In presence of alcoholic medium, the halogen atom is replaced by NH2 group. So here there is a formation of NH2. X is replaced by NH2 and you are getting HX as a byproduct. So like this the reaction takes place. This reaction is taking place in a sealed tube at 373 Kelvin temperature. The carbon and halogen bond is cleaved by the ammonia molecule. That's why it is considered as ammonolysis. Ammonolysis of alkyl halide results in the formation of amines. And when we have excess of ammonia in this, when we have excess of alkyl halide in the whole reaction mixture, then the reaction further continues. How it continues? See, if I take ammonia in the alcoholic medium, there is a formation of primary amine. This is our primary amine. So consider if I have RX, alkyl halide, in an excess amount. So what happens? The further we have two hydrogens in this further replacement. So what happens when we treat it with alkyl halide? Again, there is a reaction continues. How it continues? See, one H is replaced by R group like this. So one hydrogen combines with the halogen. So like this the reaction takes place. RNH2 is a primary amine. In presence of excess of alkyl halide, the further replacement of hydrogen by the alkyl group takes place. So there is a formation of secondary amine as a product. So the reaction continues when we have alkyl halide in excess amount. Further, this secondary amine further reacts with the alkyl halide. Another hydrogen is replaced by the alkyl group. So there is a formation of tertiary amine, and HX will be the byproduct. So again, if we have excess of alkyl halide, then what happens? We are getting a quaternary ammonium salt like this. Understood? So alkyl halide is treated with ethanolic solution of ammonia, gives primary amine. When we have excess of alkyl halide in the reaction mixture, the reaction continues and we are getting secondary amine, tertiary amine and quaternary ammonium salt as a product in the next subsequent steps. This is actually the nucleophilic substitution reaction where halogen atom is replaced by amine group. Ammonia molecule or amines are acting as a nucleophiles. They are substituting this alkyl halide. Okay, so let us write an example here. If I take CH3, if I take C2, H5, Cl as an example, when it is treated with ammonia in the ethanol medium, so what happens? First, there is a replacement of this halogen by NH2 group. So there is a formation of C2H5 NH2 and we are getting a byproduct HCl. So primary amine is formed. Ethyl chloride gives ethyl amine. Ethanamine is formed. Further, it is treated with C2H5Cl. As this is present in excess, it is treated with, it is treated with the primary amine. So what happens? Another hydrogen is replaced by an alkyl group. So there is a formation of C2H5NH. One hydrogen is replaced by an alkyl group. So we are getting C2H5 again. So there is a formation of HCl in this particular step as a byproduct. So we are getting here secondary amine as a product. Further, we have excess of C2H5Cl. Then what happens? Another hydrogen is there for the replacement. So I can write here C2H5 thrice N. So tertiary amine is formed as a product. Further, in presence of C2H5Cl, what happens? We are getting, as there is a presence of lone pair of electron on nitrogen, the further reaction continues and we are getting quaternary ammonium salt as a product. So like this we are getting quaternary ammonium salt. Ethyl chloride reacts with ammonia, gives ethanamine. Further on reaction with ethyl chloride, it gives secondary amine, that is diethyl amine is formed as a product. Further, it is treated with ethyl chloride. There is a formation of NNN triethyl amine. And further, it is treated with ethyl chloride. There is a formation of a quaternary ammonium salt. So like this, the reaction takes place. This whole reaction is considered as ammonolysis of alkyl halide. It is a nucleophilic substitution reaction where ammonia or amines will be acting as a nucleophile and which are replacing the halogen from the alkyl halides. Halogen is replaced by the NH2 group or the amines. So in this particular reaction, we have to concentrate that when we get this mixture of amines, when we have alkyl halide in excess. What if we have ammonia in excess? If we have ammonia in excess, we are getting primary amine only as a major compound. Okay, so when we have ammonia in excess, we are getting maximum amount of primary amine as a product, whereas if we have alkyl halide in excess, we are getting like this mixture of amines. And as this particular reaction gives a mixture of amines, it is not suitable for preparation of primary amines to a large extent, as it is giving mixture of compounds as a product. And also, this method is not preferred for the preparation of aryl amines, because to get the aryl amine, we have to take aryl halide as a reactant, that is C6H5Cl we have to take, and this aryl halide is not undergoing nucleophilic substitution reaction so easily. So that's why this method is not preferred for the preparation of aryl amines. I'll show here how the reaction takes place. Actually, ammonia, as it is having a lone pair of electron, nitrogen carries a lone pair of electron, because of which it acts as a nucleophile. This acts as a nucleophile. So this nucleophile on reaction with alkyl halide. So when here X goes out as X minus, and this lone pair of electron, as it is a nucleophile, it attacks the alkyl group. So there is a formation of RNH2, and here you are getting HX as a byproduct. So like this, the reaction takes place. Actually, instead of, you are not getting directly RNH2, first you are getting a substituted amine like this. We are getting here RNH3 plus X minus. Actually, like this, we are getting a primary amine salt is formed, which on further reaction to excess of ammonia, we get the primary amine. Like this, actually the reaction takes place. So here, if I take a primary amine, this is our primary amine. Further, this primary amine form in presence of excess of alkyl halide. Again, the reaction continues, which gives a secondary amine. How it reacts? See, nitrogen carries a lone pair of electron. This will be acting as our nucleophile. So this goes and attacks here. X goes out as X minus. So results in the formation of RNH R. Here, if we take different alkyl halide, we get R dash. If it is same, then we can write it as R only. So we are getting R2NH. That is our secondary amine. So like this, it continues. Further, when it is treated with the alkyl halide, there is a lone pair of electron on nitrogen, acts as a nucleophile, attacks the alkyl group because X goes out as X minus. So like this, these are acting as a nucleophiles. These are acting as a nucleophile. So this is possible when we have here alkyl group. If it is an alkyl group, this is easy. But if it is an aryl group, already this aryl group is having so many electrons, 6 pi electrons are already present there. So it is not showing that much of affinity with the nucleophile. As it is already electron rich in nature, it is not attacked by, there is no affinity between a nucleophile and the arene system. So that's why this process is not suitable for the preparation of aromatic amines. The third method of preparation of amines is reduction of nitriles. So nitriles are subjected for reduction, results in the formation of amines, that is when nitrile is nothing but the cyano compound. There is a triple bond between carbon and nitrogen. When this is subjected for reduction, there is a formation of amines. So the hydrogen is added across the triple bond. So this is the reduction of nitrile to give the amine. Here we can use many reducing agents. So which are those reducing agents used for this reduction of nitriles? We can use here lithium aluminium hydride as a reducing agent in the ether medium. This can be used as a reducing agent. The second reducing agent, we can use normal catalytic hydrogenation, that is hydrogen gas is passed over the substrate in presence of nickel, platinum or palladium catalyst. This can be used as a reducing agent, or we can also use sodium amalgam in ethanol. Even this can be used as a reducing agent. Sodium amalgam in presence of ethanol. So these are the three reducing agents which are used for the reduction of nitriles to respective amines. Okay, and here the use of sodium amalgam in ethanol for the reduction of nitriles to the amine is known as, Mendel's reduction. Only this one. Reduction of nitriles to the amines by using sodium amalgam in ethanol is considered as Mendel's reduction. So here alkyl or aryl nitriles are treated with any of these reagents. It undergoes reduction to form respective amine. So for example, I'll write here one example. If I take CH3CN, if it is treated with hydrogen in presence of nickel catalyst, there is a formation of CH3CH2NH2. So here we are getting ethanamine as a product. This is methyl nitrile and this is ethanamine is the product, ethyl amine or ethanamine. If I take C2H5CN, then we get here what we get, C2H5CN. If I take this as an reactant, if I take same reagent or if I consider lithium aluminium hydride in ether media, so the product formed will be C2H5 is nothing but CH3CH2. And again we have CN which is reduced to form CH2NH2. So we are getting here propanamine. So you can see that here we have 2 carbon atoms in the alkyl chain to the functional group. Here we have 3 carbon atoms. So propanamine is the product here. So to increase the number of carbon atoms in the amines, to ascend the amine series, we can use this particular method of preparation. What if I take here benzene ring? Instead of alkyl group, if I consider benzonitrile, if this is our reactant, and if I do any of this, if I use any of this particular reducing agent, either I can take lithium aluminium hydride or sodium in ethanol or hydrogen in hydrogen gas is passed through the nickel. This results in the formation of CH2NH2. CN is reduced to CH2NH2. So like this we are getting the product. This is benzylamine. It is not benzenamine, it is benzylamine. Okay. So the side chain substitution, side chain reduction takes place. It is not to the benzene ring. So this is an alkyl amine. It is not aryl amine, it is alkyl amine, as we have an alkyl chain. Side chain is present here to the benzene ring. So like this, the reduction of nitriles takes place to form respective amines. Primary amines are formed as a product. Instead of cyanide, if we have isocyanide like this, if we have this compound, what happens? So the reduction takes place in this to form RNHCH3. So like this the reduction takes place. So we are getting secondary amine when we take isocyanide. When isocyanide is subjected for reduction by using same reagents, there is a formation of secondary amine. The reduction results in the formation of, or the hydrogen adds across N triple bonds carbon like this, NHCH3. Like this it undergoes reduction. Whereas in Cn it is giving CH2NH2, for NC it is giving NHCH3. So by using isocyanides we can get the secondary amines. The fourth method of preparation of amines is reduction of amides. Amides are the compounds which are represented by RCONH2. So when these compounds are subjected for reduction in presence of lithium aluminium hydride, there is a formation of amines. Like this the reaction takes place. Amides are having the functional group CONH2. So when amide is treated with lithium aluminium hydride followed by hydrolysis, results in the formation of RCH2NH2 instead of CO. Here oxygen, whatever the CO bond is there, that is reduced to CH2. So here we are getting amines. Like this the reaction takes place. Amides on reaction with lithium aluminium hydride results in the formation of amines. For example, if I take acetamide CH3CONH2, when it is treated with lithium aluminium hydride, always on reaction with lithium aluminium hydride we are doing hydrolysis. It is always followed by the hydrolysis to get the final stable compound. So there is a formation of CH3CH2NH2. Acetamide results in the formation of ethanamine. CO is reduced to CH2. Similarly, if I take here C6H5CONH2, that is benzenamide. So if I take benzenamide and if I do the same reaction with the reagents, it also undergoes reduction to form CH2NH2. Or alkyl amine is formed, that is benzyl amine is formed here. It is benzyl amine. So like this the reduction takes place. Amines on reduction gives respective amines. Here the number of carbon atom is same in the product as well as in the reactant. The fifth method of preparation of amines is Gabriel phthalimide synthesis. This is the most convenient method of preparation of pure primary amines. In this particular method we are using phthalimide as a main reagent. So phthalimide is treated with phthalimide is treated with ethanolic potassium hydroxide KOH gives potassium phthalimide. It gives potassium phthalimide, which on heating with alkyl halide, gives N substituted phthalimide. this upon subsequent hydrolysis, this upon alkaline hydrolysis gives corresponding primary amine. So, Gabriel phthalimide synthesis, in this phthalimide is treated with ethanolic QOH, which gives potassium phthalimide. Potassium salt of phthalimide is formed, which on heating with alkyl halide gives N substituted phthalimide, which upon alkaline hydrolysis gives corresponding primary amine. This is the Gabriel phthalimide synthesis. So what is the reaction? Phthalimide is this compound. This is phthalimide. Nitrogen. This is phthalimide. So this phthalimide on treatment with alcoholic QOH, because if it is a water medium, then it may undergo hydrolysis, so that's why we have to maintain the alcoholic medium so that we get our required product. So what happens when it is treated with potassium hydroxide? Here this is replaced by K, that is we are getting instead of H we are getting potassium. So we get potassium salt of, this is an acid, this is a base, so we are getting an salt. Okay, so with the release of water molecule. So this is our potassium phthalimide. So this potassium phthalimide on further treatment with alkyl halide, what happens? Here this potassium phthalimide will be acting as a nucleophile. So X goes out as X minus, and this is as nitrogen carries a lone pair of electron. Here this will be attacking the alkyl group and acts as a nucleophile. So nucleophilic substitution takes place to the alkyl halide. So what happens? Here we are getting X goes out, so nitrogen combines with the alkyl group. So the product form is CO N, alkyl group is now connected with the nitrogen. So this is our N alkyl phthalimide. This N alkyl phthalimide. This is our substituted phthalimide. This on further reaction with sodium hydroxide undergoes hydrolysis. In the aqueous medium, the hydrolysis takes place. So when it is treated with aqueous sodium hydroxide, the hydrolysis takes place here like this. Okay, so the final product form will be we get a sodium salt of phthalic acid as a byproduct, and RNH2 is our main product. Primary amine is formed as a product. So this is further subjected for hydrolysis, results in the formation of phthalic acid, which is further used to prepare the phthalimide. This is our phthalimide. So phthalimide is first treated with potassium hydroxide. This is an base, it is an acid, forms a salt. Potassium salt of phthalimide is formed, which on treatment with alkyl halide undergoes nucleophilic substitution, where this phthalimide is acting as a nucleophile, replaces the halide ion, forms N-alkyl phthalimide, which on treatment with aqueous sodium hydroxide undergoes hydrolysis. These bonds are cleaved and there is a formation of primary amine as a major product, and we get sodium salt of phthalic acid as a byproduct. Okay, so this is the general reaction for Gabriel phthalimide synthesis. This is very, very important for 3 marks. Most of the time asked in the examination. And here you should remember that this method is only for the preparation of aliphatic primary amines, because as you know, here the reaction taking place between the alkyl halide and the phthalimide is a nucleophilic substitution reaction. So if in place of R, if we have a aryl group, the nucleophilic substitution will not take place, and that's why we are not getting aryl amines. So it is not suitable for the preparation of aromatic amines, because the nucleophile generated or the anion of a phthalimide is not attacking the aryl halide. The nucleophilic substitution reaction is not possible. That's why we are not getting aromatic primary amines by using Gabriel phthalimide synthesis. That is the limitation of this particular method. So they may ask you to write the example for or explain with an example. So when they ask you to explain with an example, you have to write some particular example. For that you can take here in place of R, you can take any alkyl group and X any halogen. So if I take here CH3Br as an example, so what happens? This is all same, only we have to change the Rx. I am taking here CH3Br, so we will be getting here NCH3. So the product is N-methyl phthalimide. It is N-methyl phthalimide. On reaction with sodium hydroxide, hydrolysis takes place to form CH3NH2. So methenamine is formed as a product. This will be the example. The last method of preparation of amines is Hofmann's bromamide degradation reaction, or it is also called as just Hofmann's bromamide reaction, where the primary amines are prepared. So the primary amines are prepared by this particular process by the treatment of amides with ethanolic or aqueous sodium hydroxide or potassium hydroxide in bromine. So amides on treatment with bromine in aqueous or ethanolic sodium or potassium hydroxide solution, sodium hydroxide or potassium hydroxide, gives primary amines. In the Hofmann's bromamide reaction, amides are treated with bromine in aqueous or ethanolic sodium hydroxide, which gives primary amine. So the reaction is amides are RCONH2. These are acid amides. So RCONH2, when it is treated with bromine in presence of sodium or potassium hydroxide, results in the formation of primary amine. Here there is a formation of RNH2, and the byproducts in this process is sodium carbonate, sodium bromide and water. So to just balance it, you can write it as 2NaBr and 2H2O. So this is the complete reaction. Amides are treated with bromine in sodium hydroxide, ethanolic or in the aqueous medium, results in the formation of primary amine. And here you can observe that the number of carbon atoms in the amide and in the amine. the number of carbon atoms is reduced when we get the product. It is clear when I'll write an example. So if I take here CH3CONH2, when it is treated with bromine in NaOH, it gives CH3NH2. So here we have 2 carbon atoms in the reactant, whereas here we have only 1 carbon atom. So from amide to amine, there is a reduction of 1 carbon atom. So there is a formation of methenamine when it is treated with, when the acetamide is treated with bromine in sodium hydroxide. So methylamine or methenamine is formed as a product. In this particular reaction, you can observe that there is a migration of alkyl or aryl group from carbonyl carbon to the amine group. So when this CH3 is migrated from carbonyl carbon to the NH2, we are getting the primary amine. So this will be going out and reacting with sodium hydroxide, releases sodium carbonate and further sodium bromide and water. So like this, the reaction takes place. This is also a very important reaction for the examination. 2 marks. For 2 marks, they'll ask this particular question. Explain Hofmann's bromamide degradation reaction with an example. So, in this reaction, amides are treated with bromine in aqueous or ethanolic NaOH or KOH gives primary amine. This is your general reaction and this is the example. And here, in this particular reaction, what we have to observe that the number of carbon atoms is reduced when it is forming the amine. And there is a migration of alkyl group from carbonyl carbon to the amine group. We'll write another example for the same Hofmann's bromamide reaction. That is, if we take aryl group, that is, if we take benzenamide, this is benzenamide, when it is treated with bromine in sodium hydroxide or potassium hydroxide, what happens? So the same thing, this aryl group is now migrating to the amine. So there is a formation of aniline like this. So the byproducts are same, 2NABr plus 2H2O. So this is another example. So here we are getting aryl primary amine. When we take benzenamide, it is treated with bromine in presence of ethanolic or aqueous NaOH, we get aniline as a product. You may ask in the examination how we get aniline from benzenamide. So by Hofmann's bromamide degradation reaction, we can get the benzenamide or aniline. Okay, so these are all the methods of preparation of primary amines.